Good to go. All right. Hi, everybody. Happy Monday. I'm Rachel Chapman. I'm an assistant professor of sustainable ag at the School of Food and Ag. I sit over in the Roger Clack greenhouse. It is my pleasure to introduce you today to John Bumgarner, who is the director of the New England USGS. Sorry, I got it backwards. The USGS New England Water Science Center. The Water Science Center has been a great partner for me over the past couple of years in my research program. Joe Ayotte is standing in the back of the room. He is a research hydrologist who I've had the good fortune of working with. And he helped brainstorm bringing John to come and speak with us, which we're really, really excited about. John has been a Water Science Center director in New England for just the past couple of years. Before that, he was the director of the New Mexico Water Science Center. He's worked for USGS in many different parts of the country, including Texas, New Mexico, Minnesota, and now we are very, very lucky to have him with us in New England. He's a graduate of the University of Texas in Austin and has also had experience working in environmental consulting. So wide breadth of experience as well as depth of expertise. And we are so excited to hear from you today, John.
Thank you very much, Rachel. And I'm very excited to be here. I'm just happy to see people in person. So I started at the New England Water Science Center 1 month before the pandemic. So I was the director from the basement for about 2.5 years, and seeing people in person, honestly, I don't know what to do with my face. I just smile a lot. So thank you all for attending in person. Again, I'm really excited to be here. What a phenomenal speaking series that you have here at the University of Maine. Credit to David for inviting me to be part of this. I very much appreciate it. So as Rachel mentioned, I am John Bumgarner. I'm the director of the USGS New England Water Science Center. And today's talk is serving our communities with science. How exactly do we connect the science that we're doing with the communities, the end users that need to leverage that science to make the decisions that they need to make? So that's going to be a lot of what I'm going to be talking about here today. So to kick us off, first, one disclaimer. There will be audience participation. So just brace yourselves, be centered, get ready for it. Don't worry, it's not going to be like a sing-along or an interpretive dance, although now I kind of want to do that I've said it out loud. But there won't be anything like that, but I will be asking you to raise your hands at different parts, okay? All right, here we go. If I can get this to advance. There it goes. All right. A brief orientation, very brief orientation on the U.S. Geological Survey. I took for granted this morning that everyone knew who the USGS is, and unfortunately that's not the case. So like I said, a very brief introduction. We are one of the bureaus, one of the 11 bureaus in the Department of Interior. Secretary Deb Haaland is a cabinet secretary in the president's cabinet. And the USGS, as you can see, along with the Park Service, Bureau of Reclamation, Fish and Wildlife, we are all bureaus in the Department of the Interior. We were established by the Organic Act of 1879. No, I will not require you to read the entire Organic Act and the bill that established us, but it's there, or the act, excuse me. The one key point that I want to make about the USGS is that we do not have any regulatory or management responsibilities. What that means is we are strictly scientists. All we do is provide data, interpretations, information to the folks that do have to set the regulations, make the policy, make the management decisions. All right, this is a very important distinction. We are actually forbidden from advocating for any particular policy or decision. We are strictly to provide the information that hopefully those decisions are based on. We are guided by our fundamental science practices. So the fundamental science practices are a set of standards, requirements, processes, policies in place to assure that the information we deliver to the public is of highest quality. It involves our publication review process, which sometimes I lose count of how many people have actually reviewed a publication before it goes to be a scientific report or to a journal for a journal article. The data that we produce go through extensive quality assurance and quality control measures to test the veracity of those data before they're released to the public. And the other part of our fundamental science practices is that the information we produce is completely open and transparent. It is available to all of you in the public. Anytime you want to see it, it's available online. So our publications are not available until they're published, but once they are, whether it goes to a journal, usually there's a fee that a journal may charge to make it open to the public, and we always pay that fee so that anyone has access to it. Data are generally immediately available online at the National Water Information System as soon as they are QA/QC'd, and even sometimes even beforehand. So with our stream gauging data, for example, the stream gauges, you go out, you want to know how much flow is in the river, there's potentially flooding, the Weather Service will post it on the news. Those are our data. And those data are actually available generally in 15-minute increments online anytime you want to see them. Okay. All right. So again, this is a very brief overview. If you have more questions about the USGS, I'm happy to talk to you afterward. Okay. Our current director is Dr. David Applegate, and we have almost 8,200 employees in offices across the nation, and our headquarters is in Reston, Virginia, which is right outside of DC. Okay. A little bit more, the USGS mission. I'm going to read this verbatim. USGS mission is to monitor, analyze, and predict current and evolving dynamics of complex human and natural Earth system interactions, and to deliver actionable information at scales and timeframes relevant to decision makers. And you see some underlining there. We are to monitor, analyze, and predict. Nowhere does it say advocate. We are to deliver this information in a time frame and scale that's relevant to decision makers. We have to make sure that as civil servants, that the data and information we're providing is actually usable by the public. We are civil servants first and scientists second. Okay. The vision statement for the USGS: lead the nation in 21st century integrated research, assessments, and prediction of natural resources and processes that meet society's needs. So the integrated part, it's underlined. If you look at the other side of the screen with the figure, there are 5 mission areas within the USGS. They are core science systems, ecosystems, energy and minerals, natural hazards, and water resources. So as you can imagine, that's a pretty broad array of science that we provide, from volcanoes to bugs and bunnies to water. You name it, if it has to do with the natural sciences, we do it. 8,200 employees across the landscape. All right. These mission areas are also the areas that when Congress appropriates funding and sends it to the USGS, they go within the strategic priorities of these different mission areas. And then we, as the science centers, the science we produce align with those strategic priorities. Okay, so that's kind of how it works up and down. All right, a little bit more. There's something over the top there. Let me get that off.
Yeah, you can click it.
That is hard to do. Oh, it's right there. I could be looking down at that. I'm looking up here. Okay, so ensuring our science is relevant. How exactly do we do that? Well, for it to be relevant, we have to have conversations. We have to be talking to the folks who are actually going to be using the science, connecting science with policy and management decision makers. How do we have those conversations? We identify who is making the decisions on the landscape, whether it be a state agency, a local agency, a tribal agency, another federal agency, and we engage in a conversation. We find out what policies they're going to be setting, what management decisions they need to make, and those policies and management decisions frame the science that we do. They don't influence the science we do or how we do it, but they frame the science that we do. And then the science we produce hopefully is information they use to prop up the decisions that they make. Stakeholder and end user engagement, participatory and co-produced research. This is really important. Something that, we've not always been great at. The science sometimes happens in a black box for scientists. We get We get zeroed in on what we're doing and the blinders go on, and then all of a sudden that's all we're working on. Making sure that we look up often enough to see who we can be working together with collaboratively to co-produce science. Particularly engaging our tribal partners, making sure that we are integrating the science we're producing with traditional knowledge to have a more robust understanding of our environment, coming at it from two different perspectives. Partnering with other disciplines, including the social and economic sciences, environmental justice, human-centered design thinking, usability, and communications, as well as behavioral psychology and anthropology. Understanding that intersection of the natural sciences and the world that we actually live in and the decisions that we need to make, the decisions can't always be based on science alone. There are economic factors, there are social factors, there are other considerations for management and policymakers to keep in mind. 4 strategic goals laid out here for the entire USGS, and these strategic goals align with the White House priorities. This administration's priorities, they are reflected here. So enhance tribal engagement, meet the needs of underserved communities, enrich the value of our science through participatory research, and broaden inclusion of expertise from other fields. All right. Okay, so that is, as I mentioned, a brief, very brief overview of the USGS. With 8,200 employees, 5 mission areas, and countless offices across the landscape, you can only imagine the mile-wide science that we're doing. But as I like to say, it's not a mile wide and an inch deep. It's a mile wide and a mile deep, because we have internationally recognized experts working on each of these different subjects often. And so therefore, the depth of knowledge and expertise for me personally is humbling. These are the folks I get to work with every day. All right, so USGS Water Science Centers. Water Science Centers are just one type of science center. We also have volcano observatories. We have the Earthquake Science Center. We have the Eastern Ecological Science Center, the Woods Hole Coastal and Oceanographic Science Center. Water Science Centers are just one type in the survey. And today I'm going to be talking mainly about the New England Water Science Center, using it as an analog or a representation for all of the other science centers that are out there. All right. So water science centers, you can see on the map, I know it's a little small, but all of those points represent an office where folks that are working for a water science center sit. And you can see Puerto Rico, Hawaii, Alaska, the lower 48, we have offices just about everywhere. And the really cool thing about that is that means that the folks producing the science for our communities likely live in those communities. So we are benefiting not only the communities that are receiving the science, we're benefiting ourselves because we live there. So it is a dynamic and very personal relationship that we have with these communities that we live in. Therefore, it's much easier for us to engage with those communities when deciding what science we're going to produce. Okay. I'm going to say community a lot today. I'm already tired of saying it, but please don't get bored with it. It's going to be the kind of cornerstone of the presentation. So you're going to hear community a lot. All right. So with water science centers, science produced by water science centers aligns with the USGS mission areas. As you can imagine, a lot of it aligns with the water mission area. Makes sense. But we also work for the other mission areas as well. There are 28 water science centers with offices in almost every US state and territory. And staff in the different water science centers, we often have comparable expertise. We may have a groundwater flow modeler in every office, or a geochemist, or stream gaugers. We have those in every office, but we do still collaborate, particularly on larger projects or programs. Or if someone with a particular expertise sits in an office, that expertise is not redundant in another office. We have one of the national experts on PFAS sitting in our office in New England, and she has a laboratory actually in Virginia, or West Virginia, excuse me. And she works nationally and wrote the strategic directives, the lead author for the USGS for PFAS. So as a result, a lot of other water scientists actually consult with us and work with us for her expertise. There are similar experts in other water science centers that we engage with whenever they have an expertise that we don't necessarily have. And then finally, as I mentioned before, the New England Water Science Center, the work presented here is simply a subset of the work we're actually doing in the center, and is a very small subset of the work actually happening across the landscape within the nation and internationally. All right. So now for the New England Water Science Center, us specifically, 8,200 employees in the USGS nationally, 170 of them, a little over 170 are in New England. We have 5 offices. We are in Montpelier, Vermont, Concord, New Hampshire, or Pembroke, New Hampshire, Augusta, Maine, in East Hartford, Connecticut, and Northborough, Massachusetts. So from those offices, as you can imagine, we have folks that commute to those offices that live likely in the same communities that you do. We have hydrologic technicians, hydrologists, physical scientists, biologists, administrative staff, IT specialists, technical specialists, and program managers. It is, again, a broad array of different expertise that we're bringing to the table, not just scientifically, but we have a phenomenal information specialist we just brought on board to help us better communicate the science that we're delivering to our communities. The staff range from early career students and recent graduates. We're likely about to hire 9 to 12 students to work in the office. And these are students that are going to school and completing their education while at the same time completing scientific studies and data collection and research at a USGS office. And all the way to internationally recognized experts. We had 2 staff just in the past year. One went to Uzbekistan and another one to Mexico to consult on science that's being conducted in those nations. All right. The vision for the New England Water Science Center is leading in public service by providing relevant, accessible, and innovative water science to New England and the nation. I'm going to unpack that just a little bit. Science wasn't the first word mentioned. It was public service. Public servants that's who we are. Scientists, of course, is also who we are, but that service to the public is the cornerstone of what we do as federal scientists. And then with providing relevant, accessible, and innovative, it's not enough to just do really cool science. It has to be relevant on the landscape, and it needs to be accessible through our website, through our national water information system, our publications, these types of presentations. We need to make sure that we're engaging with the public that we're supposed to be serving. We have about 600 real-time and over 300 routine monitoring locations. So 600 real-time monitoring locations, meaning that, say, let's take a stream gauge. It's collecting stream flow information from that river or from that stream. Every 15 minutes, it's transmitting that data to a satellite, which then goes into our database, and you can see it in real time on the web. So that's what a real-time data collection site is. And then routine monitoring, we have maybe monthly samples we're taking for water quality, all right? Over 50 ongoing studies. So ongoing studies could be groundwater flow modeling. It could be a geochemical analysis of an area. These studies are finite in nature in that they are 3 to 5 years, generally speaking. And then at the end, you may have 1 or multiple publications that are interpretive in nature. So it's not just the data being delivered, it's an interpretation of those data. And then finally, 60 scientific publications and countless data points, easily tens of millions of data points released in federal fiscal year 2022. So tens of millions, you can do the math easily, 600 real-time sites transmitting 15-minute data, that's over 20 million data points right there. Okay, here's the interactive part. Everybody ready? You centered? It's the interpretive dance? No? No one's joining me? Come on. All right, so what I want you to do is close your eyes. A couple of you already have your eyes closed, so we're good. Close your eyes, come on, play along. You're like, okay, what kind of talk is this? Just close your eyes and picture a community. Have that captured in your mind, that picture of a community in your mind. And hold on to that. For as we go through, I'm going to be asking questions about that. Okay. All right. So you can open your eyes again, even those that had your eyes closed beforehand. And we're going to frame the question a little bit. First, let's define our terms. We're going to go Socrates on this. We're going to define our terms. And I explored a lot of different definitions. And these were the two, even though they were Google, that I liked the best. They really got to the essence of the other definitions that I found. So the first one, a group of people living in the same place or having a particular characteristic in common. I view that the way I interpret it, it's kind of happenstance. Either you happen to live in the same area or you happen to share characteristics. The second one, a feeling of fellowship with others as a result of sharing common attitudes, interests, and goals. I interpret that as a choice. So you have happenstance and choice. You have a sense of fellowship because you have shared attitudes, interests, and goals. Those are choices that you make. So that's how I kind of categorized it in my mind. Have your own interpretation. It's not the only one, obviously. But then asking questions, let's refine. If we start exploring the type of science that we might need to do, what are the characteristics of the communities that might need that science? Or when we're engaging with the community, what kind of questions do we need to ask about that community as we develop the science that they need? So what are the components of a community? Is a community just people? Could it also be plants and animals and other parts of the environment? What is the scale of a community? What are the values of a community? How many communities can someone belong to? How is a community organized? Is it organized or is it just utter chaos? Who in the community are getting their needs met and who aren't? This is a critical question, particularly if we are going to effectively provide information to and engage with underserved communities. Let's identify who hasn't historically had their needs met, and let's work on that together, right? And then finally, how do we merge the first two definitions? How do we go from happenstance to choice? How does it become, yeah, we happen to all live in the same place, but now we have shared goals and attitudes. How do we get to that place? Okay, so now I'm waxing a little philosophical here, but sorry that now you're trapped in the audience and you have to stick around. I think this is a class and you get credit for it, right? So I got you here. Okay, so we've gone through that. Now here's the first question. Whenever I said picture a community, and those of you online, if you want to raise your hands and if you played along at home, who of you pictured a neighborhood or farming community? Okay. Actually, the majority of folks in the room raised their hands. They pictured a neighborhood or farming community. So this is science that we're doing that directly affects neighborhoods, farming communities, individual families even. The project is to test a novel shallow well design that may provide contaminant-free water to domestic well users in arsenic-prone areas. Here's the critical question. Why? Why would we do that? And often the answer for scientists is we're doing that because it's cool, because it's innovative, because it's pushing the boundaries of science. But why? Why do we need that science? Well, in this case, exposure to arsenic in groundwater has been linked to adverse human health effects. It makes people sick. It's really straightforward. Why do we need this science? Why do we want to develop? And by the way, Joe in the back of the room, he's the patent holder for this well design, and we're actually collaborating with Rachel here on this type of work. So this is work right here in your community that's happening, okay? Why do we need this? Because folks are getting sick. And how do we design something? How do we do science that can help folks from getting sick? It's really straightforward. The objectives determine whether enough water can be produced by the new design. Yeah, it's great. It keeps all the arsenic out. It keeps the water out too. No, we don't want to keep the water out of the well. We want it to be able to produce enough water that it's usable. And also determine if we can eliminate arsenic and at the same time prevent other contaminants from being caught in the well. That close to the surface, you are in danger of other potential surface contaminants. Thankfully, the design so far is proving out that, yeah, it's, reducing those or eliminating those contaminants as well. So we're going to keep testing that to make sure that as we distribute these to neighborhood and farming communities, that it's a viable option for the production of water. Okay, so the cooperators and collaborators, I've grouped them together. Cooperators for us, those are funders of science. So generally speaking, with water science centers, we have appropriated dollars, but we also work with other agencies, whether they be federal, state, tribal, private, local organizations and agencies that provide funding for the science that we produce. They provide funding and intellectual resources to the science. Collaborators provide intellectual resources to the science that we produce. I've grouped them together here. So the collaborators and cooperators on this project, University of Maine, Maine Geological Survey, New Hampshire Department of Environmental Services, University of New Hampshire, and Environmental Protective Agency. So you can see there's a broad array of collaborators, co-produced science. How do we engage with our communities to make sure they are getting their needs met by the science that we're providing? So this is how I've organized just about every slide going for the rest of the time here. So now you know what's coming, a little bit of foreshadowing. And so we're going to go through that with, again, the most important question here is why? Why are we doing this science? And yeah, sometimes we do science because it's cool and because it's innovative, but really, if we are able to understand the societal need behind that science, that makes it that much more powerful. Okay, next up, whenever I said community, who thought statewide? Did anyone think of their state? Anyone think of, I live in Maine, this is my community? Okay, yeah, not very many. Stretch your idea of what community means. You know, yeah, it could be a neighborhood or farming community or your town you live in, but it's also, you have an identity associated with your state. And these are folks that you live and interact with every day. They deserve your best effort as you do theirs, right? So thinking about this in terms of statewide communities, how do we provide science to meet the needs of an entire state? So the project I'm going to talk about here is PFAS concentrations and partitioning in soils, biosolids, and water in New Hampshire. I have to admit, I keep forgetting this is down here and I keep looking back up there. So this project with PFAS, why are we doing it? Well, similar to arsenic, PFAS exposure has been linked to adverse human and environmental health effects. It's bad for you, makes people and environments sick. So we need to understand, how is it distributed across the landscape? How does it mobilize in the landscape? If it's distributed in soils, as rain percolates through those soils, how does it pick up those contaminants and take it to your nearby well for drinking? So understanding this distribution and the fate and transport is critical for us to understand what the danger is from PFAS. So the objectives, statewide characterization of PFAS in soils, and I do have a couple of URLs here that you can scan those. The first two objectives have publications associated with them. They're going to be the only ones throughout the whole presentation. All of these projects are current and ongoing, and we have not yet published, okay? This is an exception where there are a couple of publications already available. Analyze PFAS soil water partitioning in the lab. So great, you've got PFAS in the soils, not great. But what happens whenever it rains? Well, let's take it into the lab, that soil, and with the PFAS, and let's run water through it. And let's figure out how much of the PFAS stays sorbed or stuck to the soil particles, and how much of it gets dissolved into the water and transported down gradient, right? Then the last part, compare the field scale. Let's do this in the field and compare it to our laboratory results. You can often do things in the lab that then you take it out into the natural environment and it behaves totally differently. So let's take this to the natural environment, compare the two so we can test the veracity of the laboratory experiments. Part of that QA/QC process, right? Cooperators and collaborators, it's a short list this time. It's the New Hampshire Department of Environmental Services. Obviously, there are other scientists that we've collaborated with over time, but directly, this is who we're working with on this, okay? All right. Next up, Whenever I said community, who thought a local community like your town? Okay, many people. And how many people thought international? I mean, we share a border here with Canada, right? Aren't they part of it? We're all on North America. Isn't that part of our community? Again, stretch your thinking about what community means. It's not just the happenstance or of where you live or the characteristics that you have. It's also that feeling of fellowship and of having common goals. So if we have shared resources with Canada, then we have common goals with Canada, right? This is a tale of two gauges. Don't ask me which one's London and which one's Paris. I didn't try to figure that out, but for those of you who have read the book, you'll know what I'm talking about. The tale of two gauges, the reason I have it like this is that these are stream gauges in two different locations. We've got one stream gauge here at Branch Brook and one here on the St. Croix. Same instrumentation, same methods of data collection, same type of data being produced. Two dramatically different reasons, two different whys for why we're doing this type of science, why we're collecting these data. With Branch Brook near Kennebunk, Maine, why are we doing this? Well, Branch Brook is the primary source of drinking water for 75,000 people in 6 communities. We need to understand how much stream flow is in that river so that they know when they can divert water from the river and when there's not enough flow so that they know whether or not they need to tap into groundwater resources, okay? That is the why we have that stream gauge deployed there. Same stream gauge, different spot over on the St. Croix. Why are we doing this? Well, the St. Croix is an international watershed and vital resource for communities on both sides of the border. Wow, now we've got fractals going. We've got communities within a community, right? So this idea of community does not mean one specific thing. It is how exactly do we connect with those folks and those environments and habitats that need the information that we're providing? And how do we co-produce that? How do we engage in the conversation with all of those communities to make sure we understand exactly what science we should be doing to answer the questions they need to answer? So with this on the objectives, support stakeholders and the International St. Croix Watershed Board, which helps to prevent and resolve disputes over the water, over the river, monitors ecological health, and ensures dam operations comply with the orders of approval. It's an international treaty. So you can see 2 different locations, same instrumentation, 2 different whys, both critical in helping folks in communities make their decisions. Okay. Our cooperators and collaborators, the International Joint Commission, the Passamaquoddy Tribe of Indian Township, Environment Canada, and Woodland LLC. Up above, we had Kennebunk Port, and the Wells Water District. These are a lot of conversations happening. There's a lot of talking going on. And yeah, believe it or not, I can talk a lot. I'm sure you figured it out by now, but I'm not the only one doing the talking. We have 170 staff that at some point or another, they are engaging with the communities that they're serving. And I'm going to follow on with that. We have 170 staff in this water science center. There's 28 water science centers. So again, doing the math, we're one of the larger science centers in the nation, but this is happening in communities from Las Cruces, New Mexico to Minneapolis, Minnesota, to New England, over to Alaska, Puerto Rico, you name it. Okay, who thought of the nation? The United States as your community. We all live here. We're all in this community. Stretch those boundaries a little bit. Think about if you are conducting science, what is the community you're going to serve? For those of you, do we have many hydrologists or folks studying hydrology? Okay, we've got 1. All right, we've got 2. Got 2 hydrologists in the audience. Representative elementary volume. If you've ever heard that phrase before, if you do computational modeling, that is the representative elementary volume that if you're doing a computational model, that your model is appropriately used at, okay? So if I'm doing a model of a town, for the hydrology in a town, that may not be useful nationwide. If I'm doing a nationally relevant study or model, it may not be relevant locally, and we would have to telescope in to that location to get more higher resolution information, okay? Communities work the same way. It's not just the scale of the model we're producing or the science that we're doing, it's the community that we're serving. What is going to be relevant on a national scale might be relevant at a local scale, or we might need higher resolution information or study to zero in on what's going on at that local scale. This is one that, with serving national communities, this is using all of our stream gauges across the nation, which are locally based. So this is one that thankfully we can look at trends in the national data, we can also look at locally, right? The two projects, the effects of climate change on extreme and environmental stream flows, extreme being floods, drought flows, so high and low flows. Environmental flows, those flows that ecosystems and habitats need to maintain the viability of those habitats. So it's not enough to know if it's going to flow too much or too little. It's the timing of the flow. It's the intensity of the flow. So those ecosystems they require certain times of year flows and certain amounts. Why would we do this? Well, to understand how and to what extent climate change affects our water resources and include those effects in future water projections. How are we going to effectively plan for the future if we don't understand how climate change is affecting our environments? What is the non-stationarity of that environment, of those stream flows? So the objectives characterize changes and trends in extreme and environmental stream flows using machine learning, XGBoost, trend testing, you name it, and also two focused analyses to estimate changes in groundwater recharge in northern New England. So we have the national study, but then we have a couple of focused areas that we're trying other methods as well. In addition to that, environmental flows relevant to migratory marine fish in select US regions, Atlantic salmon. What do they need? How is climate change affecting their habitats? The cooperators and collaborators, University of Vermont, University of New Hampshire, NOAA, and EPA. There's actually a third project that is international that I didn't list here because it's not a national community, but it's international. And we are collaborating with scientists from around the globe to complete similar work in South America, Australia, and Europe. So this is not just something that we're doing here for the United States, but universities, other agencies in other countries that we're working with. Okay, so far, let me see if I can recount this. We've got neighborhood and farming communities. We've got a statewide community. We've got the local, the tale of two gauges with local and international, and then we've got national communities. And next up, we have tribal communities, a critical component of the mission of the USGS as the Department of Interior is engaging with our tribal partners and engaging in a way that we respect and appreciate and integrate traditional knowledge of these natural resources that they rely upon. This is one study that we're doing. This is the impact of climate change on culturally significant wetland plants and their habitat in the Meduxnakeg River watershed. I did have to practice Meduxnakeg. I said it right. I'm so glad. Why? Why would we do this? Well, wetland plants and their habitats, which are important to the Wabanaki people in Maine and are central to Holton Band of Maliseet Indian identity, are vulnerable to climate change. Really straightforward. This is why we're doing this. And ask yourself that question, whether you're doing science or any job you end up doing, why? How am I in service to the community that needs this information? Objectives. And you can see the first objective here isn't necessarily a specific product we're going to be releasing from this, but actually an approach. It's to integrate HBMI traditional knowledge with a new watershed model for the Meduxnakeg River that we recently developed. How do we integrate those two different ways of viewing the world into one way to view the world that's effective? Develop a research process that addresses HBMI climate adaptation needs for wetland plants, and outcomes could include prioritizing wetland areas for restoration and protection, and also adapting current water quality monitoring to detect climate change stressors. Okay. Cooperators and collaborators, HBMI. All right, we're going to keep going here. I'm running out of time and I've got a few more slides to cover. So next up, who thought of regional communities? Well, first, actually, who thought of tribal communities? I didn't ask that. Yeah, let's stretch this. Let's think about who are the communities we need to serve, okay? With regional communities, who thought of, I mean, we all live in New England. We're all New Englanders, right? Who thought of New England as their community? Okay, we've got one, yes, we have a couple of people. I mean, you know, we've got one football team, you know, they're the New England Patriots. So this is a concept of we do belong to multiple communities. You don't just belong to one. And sometimes it's by happenstance and sometimes it's by choice. So how do we make sure that we say, I'm a New Englander by happenstance and by choice? So with the study, the Long Island Sound study, this is a little bit different format because this is a regional initiative within the USGS. And getting it organized, we've got about 20 ongoing projects. You can see some of the list there. That is just a fraction of what we're doing. And the why is that Long Island Sound and its watershed have experienced profound changes that have negatively affected ecosystems, the 4 million coastal residents, and the tens of millions more that live in the watershed. It's a vital resource, the entire watershed and the sound itself. And I list here also the USGS Long Island Sound Study team. It includes Northeast Region Office, the Eastern Ecological Science Center, the Florence Bascom Geoscience Center, New England Water Science Center, New York Water Science Center, New England Climate Adaptation Science Center, the Science and Decision Center, and the Woods Hole Coastal and Marine Science Center. We're all working together on this. As I was saying before, whenever we have these large programs, water science centers work together and the other science centers work together as well, all leveraging the different expertise and integrating that expertise into a single USGS vision for science and sound, okay? The objectives, you know, helping policymakers and managers understand what they need to do, what information they need to make effective change for this resource. Cooperators and collaborators, EPA, the states of Connecticut and New York, and many, many others. I will also add that this is just one regional project we have ongoing. We also have the Southeast New England program that moving around the coast up onto the Cape. And our hope is that this type of integrated science approach where we're not only collaborating with ourselves, but with the federal partners in the area, with the states in the area, also moving this into the Gulf of Maine. And how can we start better serving the needs of the northern New England states in the Gulf of Maine? Okay. All right. Who thought of underserved communities whenever I said community? Okay, got a couple. This is critical. Not only is it one of the White House initiatives that we are in line with, but it's one of our personal values. Let's make sure that we can actually start effectively serving the folks that have historically been neglected. The folks in our communities that have not had their needs met, right? It's just the right thing to do. It's the bottom line. So with this project, we want to delineate urban drainage with stormwater infrastructure in the Mystic River watershed. As you can imagine, that gives hydrologists nightmares. You know, the natural landscape, we kind of understand how water behaves in a natural landscape. You put it in an urban environment with impervious cover, that figure there on the left, and then with the actual drainage locations on the right, you can't even see all those drainage locations. It's just a blob up there. But the water is behaving very differently in this urban environment. And often these urban environments are underserved communities that are potentially economically depressed, that may not have the resources that allow them to effectively manage the resources in their area. So why would we do this? Because underserved communities are often the most affected by urban flooding and water quality issues. The objectives provide a publicly accessible web tool that allows users to view the urban stormwater network and delineate accurate drainage areas. and support municipalities' efforts to reduce stormwater pollutant loading and meet permit requirements. So think about this, let's unpack it a little bit. So we've got potentially higher flooding potential in urban areas because of the impervious cover. We've got higher incidence of water quality issues because of the impervious cover and that many folks living in the same place driving cars. But on top of that, you've got potentially an economically depressed area that if they violate their permit requirements, what are they going to have to do? They're going to have to pay a fine with resources they already don't have, right? So it's just a compounding effect. So helping these communities understand not only what the immediate threats are from flooding and water quality issues, but how to protect themselves from potential fines and other, negative outcomes. Hopefully the information we can provide can help support those decisions that they need to make. All right, cooperators and collaborators, the EPA, the Massachusetts Department of Environmental Protection, the Mystic River Watershed Association, and 19 different municipalities. Okay, and I think, oh, no, we've got two more. So I'm going to go through this one quickly. Who thought the globe? Whenever I said community, I mean, we're all earthlings, right? Who thought the entire globe? Again, going from happenstance to choice. This is part of our community, and how do we service those communities around the world? This is a project that we're working on. It's a satellite-based remote sensing of river discharge. Why are we doing this? Because there are streams and rivers around the world where accessibility limits our ability to measure stream flow. The pilot project, that's the Yukon River in Alaska down below, accessing that location. I mean, if you want to take a helicopter out to your stream gauge every time, which sounds like a great time to me, obviously not a great leveraging of resources. Instead, can we use these remotely sensed, can we use the remotely sensed information to gauge streams? By taking information we have from high resolution stream gauges on similar rivers, can we compare that to the remotely sensed information and at least bracket the stream flows we're seeing? So start out in Alaska, take it to the Congo, take it to the Amazon, to the Nile, to the Mississippi, around the globe, the Yangtze. How do we understand the flows in these rivers to best manage our resources? So I talked about some of the objectives already, just with that. But part of it is also create an online dashboard to make remotely sensed hydrologic data publicly observable and downloadable. This is a critical component of what we do. I mentioned early on the transparency and the accessibility of the information the USGS produces. We want to get there with this. That is the SWOT, the Surface Water and Ocean Topography Satellite, NASA satellite that went up in December. There are already satellites that we can use for this type of imagery. This one is going to be incredibly high resolution and is a game changer where evaluating surface water is concerned. Collaborators and cooperators, NASA and the University of Ohio. And like I said earlier, I wait for the day that I can buy a USGS t-shirt at Target, not just a NASA t-shirt. I don't know if it's going to happen, but that's my hope. We'll get there one day. All right, finally. Who thought of the scientific community? Okay, we've got a kinda over there. The scientific community, yeah, we don't necessarily all live in the same place, but people say scientific community all the time, right? So how do we service the scientific community? Hopefully, all of the science we're doing in some way is in service to the scientific community. Folks can build upon the work done by others. But this is one location that is specifically designed to service the scientific community, and that is the Sleepers River Research Watershed. It's a natural laboratory in Vermont. Why would we do this? Because we need foundational hydrologic research to innovate and improve the science we do and the methods we use to serve our communities, right? I mean, yes, doing all of the applied science that I was talking about is really critical, but this foundational science is just as critical. And keeping in mind, yeah, this is cool and innovative, but also the end goal is to better serve the communities by developing methods that are more cost-effective, more accurate, more reliable. The objectives, I already talked about that a little bit. Something different here is notable contributions. So we only have one hydrologist in the, or 1.5, 2, he kind of raised his hand. So we've got a couple of hydrologists in the audience. So Dunning and overland flow, you may not have heard of, but this is foundational to our understanding of surface water runoff. Dunnian and Hortonian overland flow, that is, again, critical to evaluating how water runs off on the surface of a landscape. That was here. That was at Sleeper's watershed. Sword catchment water dominates stream response under most circumstances. Different hydrograph separation approaches yield similar results. I know that most of you are not hydrologists, but again, these are cornerstones of the science that we do. And they were all done here at Sleepers. Okay, so serving that scientific community so then the rest of us can go out and serve everyone else. Okay, cooperators and collaborators, I just listed a few here. Folks that have come out to do work. If you want to do work at Sleepers Research Watershed, cool, let's do it. Okay. All right, now I think I've made it through all the communities. And now I'll ask the question, which communities do you serve? Really ask yourself that. At the USGS, we are civil servants and service is part of the position description, but we still sometimes miss the mark, especially when we don't take the time to engage our communities. We've got to have the conversation and you got to spend more time listening than talking. I know you're thinking John spends more time listening than talking. It's true. We got to spend more time listening than talking. We have to really engage and understand what it is our communities need from us. Whether you're a government, academic, private, or nonprofit, be intentional about service. Identify which communities you are serving or plan to serve and collaborate with them. Don't ignore them. Don't have one conversation and then go back and do your cool stuff in your office or in your lab or in your field. Engage them in the science. Consider how impactful the science could be if each of us focused on how we could be in better service to each other and our communities. Again, don't do this in a vacuum. If you're going to be doing anything worthwhile, make sure it's worthwhile for others, okay? All right, with that, a few of our contacts. I'm the director, deputy director Marcel, our branch chiefs. If you ever have a question about the USGS, regardless of what part of the USGS, just reach out to me directly. Again, I'm happy to talk anytime. You may bite off more than you can chew, but I'm happy to talk anytime and I will connect you with the right experts that you need to answer the questions that you have, okay? And the same goes for anyone on our staff. Finally, my community, I am humbled by these folks every single day. They are incredible people to work with, and I am incredibly fortunate that I had them to rely on through the pandemic and beyond. So with all of that, I thank you all very much for your attention. And we've got, I think, a few minutes for questions. Yeah. Okay.
Good. So the way we do this is Linda Silka is down the hall and connected to the Zoom audience, and she'll take questions through the chat. And I'll do any questions from the audience here. Linda, can I go first for a sec?
You bet.
I was wondering, what's the status of the USGS participation in the National Water Model? And that was, I've heard different stories about who's commanding it now and whether or not it'll continue in the same format or not. I didn't know if you had anything on that background.
Yeah, so the National Water Model, we are still fully engaged in Tuscaloosa. So the National Water Model is an effort led by the Weather Service that we are engaged with. And so the National Water Center, I think is the name of it, in Tuscaloosa, Alabama, at the University of Alabama, was established there as a national focus for hydrologic research. And so, yeah, we still have folks that are working there either physically or remotely and are fully engaged in the development of the model and the application. Thanks. Yeah.
Linda, you want to turn?
Sure. First, let me say what a wonderful talk this was, just how informative. One of the questions that came online is, it's an important one. How do you handle communities with conflicting needs?
From a distance? No, I'm just kidding. No, that is in my mind, one of the strengths of science is that it is nonpartisan, non-biased, and not being advocates. Sometimes we have the privilege of coming in and saying, this is the information. And it's also a luxury that then those folks that have maybe conflicting priorities or want different decisions, they now have the information that they need to make that decision. I mean, it doesn't mean that they're not going to agree at the end, but hopefully in the sense of community, they can come together and make the right decisions based upon the information that we provide. So, I mean, again, part of the luxury of not being advocates is that we provide the science and listen to the needs of the communities and hopefully provide the relevant science that they can use to make those decisions together. But I've worked in many situations where we have, you know, conflicting perspectives, competing priorities, and, you know, again, coming in and delivering the science, hopefully they can make the decisions after that. Did that answer the question? I wasn't trying to dodge.
Yes, yeah, no, it did. Thank you. David, do you want to ask another?
What, you got some more there?
Oh, yeah.
Okay.
So people were pretty interested, and one way it shows that people were pretty interested is that someone asked, how often does the USGS hire new graduates?
Pretty often, actually. So just our center alone, we filled, I believe it's 32 vacancies in 2022. We have over 170 staff. The vast majority of those vacancies were students and recent graduates. We just flew a vacancy for students where we'll more than likely hire 9 to 12 students that they will be able to work whenever they're not in class. They can take a leave of absence or some other you know, reduced hours whenever they are taking classes, and then they can stay on the roles throughout their entire college career, you know, depending on how things work out, of course. And then with recent graduates, we can hire them. A recent graduate is defined as anyone who's received a degree within the last 2 years, and they are eligible to apply to a recent graduate vacancy. We generally fly 1, 2, 3 of those per year, depending on the needs of the program that we have, and whether or not we've had folks advancing their careers, you know, either within the center or outside the center to other centers. We're, you know, in the process of, I'll say, losing a staff member to the Colorado Water Science Center. It's not really losing because, as I've said before, if our best and brightest are advancing their careers in government, that's good government. That's the way it should work. So hopefully we'll be able to find a recent graduate to replace this person. And now we've got 2 great people, right?
That's great. I can go on?
Yes.
Yeah, go ahead.
Okay. You mentioned that there are a number of the water science centers. How do they differ? Are there a few general things you can say about how they differ from each other?
Well, sure. You know, community needs are going to be different across the country. So it's easier to talk about how we're similar. For the most part, water science centers are divided into 2 different sides of the house, always working together and integrating. Where on one side, we have our data production. So whether it be continuous monitoring or routine monitoring. And then on the other side, you have interpretive science. So the publication of interpretations of that information. And the 2 can't exist. One can't exist without the other. So in some water science centers, there may be more interpretive program than there is data. And in other science centers, there may be more data than interpretive. In some areas of the country, like working in the Southwest, groundwater resources are a much larger focus of what we're doing because there's just not as much stream flow to be used as a resource for communities and habitat. So there may be more groundwater studies ongoing in, say, the Southwest than maybe in New England. Not that there aren't any here, it's just maybe a little bit of a difference because of the community needs.
Very interesting, very helpful. Have you come across contexts where technology has supported traditional knowledge?
A lot of that I've seen has been in direct work with different tribal partners. The work that we're doing now with with HBMI, I am really looking forward to the results that come out of this new project, knowing that the previous project that was also in collaboration and cooperation with them already produced results that thankfully they're able to use. So far, it's still a work in progress to make sure we do this right. I could say we did it wrong for a long time. So I think it's going to take us a little while until we get it perfect.
You mentioned that there are 28 water science centers. Suppose that a family or a tribal community that they wanted to do a field trip and got a bus, came to some of them, what would they find? Is there something for people who show up to help them learn about what you do?
Oh, as far as in the field with our scientists actually conducting the work, having a field trip out to do that, we've done that before. Sure, we can do that. And it really depends on the study. I mean, you can view our stream gauges at any time. You can find them on the web, their locations, you can go out and see them. Generally it's a box on the side of the road with a solar panel. And you can't necessarily see exactly what's going on with it, but we often have hydrologic technicians out servicing those gauges. And if you contact me, then I can help you connect with them and get your field trip out there when they'll be there so they can walk through what they do.
Hey, Linda, can I do the last question?
I've got a good last one too, so maybe we can sneak in two.
Let's do this one first, okay?
Okay.
I just wanted to know, like, what kind of led you to pursue this kind of career? Like, was this something that you knew you wanted to do when you were going throughout school and college and things, or is this something that you were kind of stumbled upon?
Yeah, I have to admit, and I'll get to this, my hearing's not so great.
And so
I think it
what
was,
led you to pursue this?
I think I
career?
caught most of it. So the question was, what led me personally to this career? My hearing's not so great because I'm a recovering musician and I played a lot of loud music when I was a kid. So honestly, whenever I first got out of high school and I tried college the first time, I studied English and art history. And then I dropped out because I wanted to be a rock star. So I played music for a number of years. But then I decided it was time to go back to school. And I knew I liked being outside. I knew I loved maps. And also, I come from a family of farmers, farming the Mississippi Delta, you know, my grandfather, and riding the soybean levees with him and seeing the water and how it's used by farmers, that really guided me to hydrology eventually. But I took a geology class before I took, you know, hydrology or geography or anything else, and it stuck. And now I'm a geologist. Yeah.
And I know we've run out of time, so you don't have to answer this question, but it's such a wonderful question that was asked by somebody in the audience. I want to make sure that the question gets to you is, where do the most productive collaborations come from? You going to communities, or do you have a mechanism for communities to come to you?
Oh, it's definitely both. It's definitely both. As I mentioned, any question at any time, come to me. If there are ideas about science that needs to be done in certain communities, you come directly to me and then we'll find the right experts to connect you with. But also we're very proactive about engaging not only with our state and tribal and federal partners and other agencies, but doing congressional visits, engaging with congressional staffers, understanding what the concerns that they're hearing are from their constituents. It really is a broad range of, let me back up and say it takes a great deal of effort and focused intention to make sure that we are engaging in the right way and welcoming the conversations when they come to us. So you name it, it kind of happens. Okay.
Thank you for this terrific talk. Thank you.
Thank you.